Section 1.3, complex numbers. The definition of I. The square root of -1 is what we call I, which is an imaginary number. So there's two basic properties that you need to know in order to be successful in this section. First is that I is equal to the square root of -1, or the square root of -1 is always going to give you I. Therefore, when you take I and you square it, you're always going to get -1. Again, those two properties go hand in hand. For our first example, we're going to take the square root of -121. We're going to write it as a product of a real number and I, and we're going to simplify all radical expressions. To start off a problem like this, you always want to take off the negative. So we have the square root of -121. I'm going to take that, I'm going to rewrite it as the square root of -1 times 121. Well, property of square roots says that we can take and separate them. So we have the square root of -1 times the square root of 121. The square root of -1 is I, and the square root of 121, you can do in your calculator, it comes out nicely, is 11. So we write that as simply 11I. In example 2, we have the same directions. Write as a product of a real number and I, and simplify all radical expressions. This time we're working with the opposite of the square root of -21. So I'm going to start off the same way. I have the opposite. Remember, I'm going to kind of take away that negative. I'm going to put that separately. So it's going to be -1 times 21. If I rewrite that, I now have the opposite of the square root of -1 times the square root of 21. Well, I know that the square root of -1 is going to give me I. Now I have to look at square root of 21. If you put it in your calculator, it doesn't come out nicely. It's not a perfect square. So I try to break it down. 21 is broken down into 3 and 7. Can't be broken down any further, and we have no perfect squares. So unfortunately, this square root of 21 is stuck as is. So I'm going to just rewrite the square root of 21. So -I root 21. Generally, we usually write the I last, but this isn't incorrect the way we have it written. It's just not the formal way. So our final answer is -root 21 I. And the key is to make sure that you do not have that I under the radical. Example 3 is the square root of -45. We're going to simplify it and write it as a product of a real number and I again. So we start off the same way. I'm going to separate it as the square root of -1 times -45. Okay, so I'm going to write those as two separate radicals. Square root of -1 times the square root of 45. I know that the square root of -1 is I again. Now, square root of 45 doesn't come out nice. It's not a perfect square if you plug it in your calculator. So we have to take and break down 45. What times what will give you 45? Well, I know 9 times 5 will give me 45. I also know that 9 is a perfect square. So I'm going to rewrite the square root of 45 as the square root of 9 times 5, which is something I can work with. So now I have I times the square root of 9 times the square root of 5, which is I times the square root of 9 gives me 3. The square root of 5, I don't know the square root of 5. Okay, it's not a perfect square and it can't be broken down any further, so I'm going to leave that as is. Again, if you had the answer I 3 root 5, that is fine, but we typically put the I at the end, so I'm going to write my answer as 3 root 5 I. Again, the I should not. Now that we're familiar with simplifying radicals that have a negative inside, which are going to result in an imaginary value with the I, Let's combine that with solving for x using the quadratic formula. So we're going to use the quadratic formula and we're going to get a result that has an I in it. So let's see how this works. Remember, quadratic formula, I need to pick out my a, which is a 2, my b, which is also 2, my c, which is 19. And then I need to plug them into the quadratic formula. That gives me x is equal to, if you recall, it's the opposite of b, so opposite of 2 plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 2, times c, which is 19. All of that divided by 2 times a, in this case 2 times 2. And then we begin simplifying. So we have x is equal to the opposite of 2 plus or minus, I'm just doing this step by step, the square root of 2 squared gives me 4 minus, I'm going to multiply 4, 2, and 19, that's going to give me 152. All of that divided by 4. And I simplify just a little bit further, that's going to give me x is equal to negative 2 plus or minus the square root of 4 minus 152 is negative 148. All of that divided by 4. Now I have it simplified, but I haven't reduced it as far as I can go. So let's go ahead and get a new screen so you can see how to reduce it. So again, I was left with negative 2 plus or minus the square root of a negative 148 divided by 4. So this is very similar to where we left off in the last section, but now I have a negative under the radical. But we know how to work with that. So let's go over here. Let's look at the negative 148, or the radical of negative 148, and split it up just like we were doing. So I know that's going to be the square root of negative 1 times the 148. Then I'm going to go down and I'm going to say, okay, let's take 148 and see if we can break it down. Is there a perfect square that goes into 148? Well, 148 is actually divisible by 4. 4 times 37. So I'm going to rewrite this as the square root of negative 1 times the square root of 4 times the square root of 37. And that 37 can't be broken down any further. Well, what is the square root of negative 1? I. What is the square root of 4? 2. And like I said, the square root of 37 can't be broken down, so we'll leave it as is. So the simpler way to write this is 2 root 37 I. And remember that I is not under the radical. So I'm going to go ahead over here and rewrite it. I simplified that the square root of negative 148. So negative 2 plus or minus, I've rewrote that as 2 root 37 I. All of that divided by 4. Now, this is the correct answer, but we haven't simplified as far as we can. If you recall, we have to look at these values right here and see if they have anything in common. We never consider what's under the radical. We only look at the whole numbers. All of those are divisible by 2, so I'm going to divide each of them by 2 to simplify it. So when I divide negative 2 by 2, it leaves me with negative 1 plus or minus. When I take this 2 and divide by 2, it leaves me with 1, or just simply square root of 37 I. Divided by, if I take the 4 and divide by 2, I'm left with 2. Now, in My Math Lab, they're going to want you to write it as 2 separate answers. So let's look at how you can do that. Okay, there's a couple different ways. So let me grab my eraser and make a little room for us. Remember, we have 2 solutions. One is with the plus, one is with the minus. So let's write them out separately. The first one is negative 1 plus root 37I divided by 2. And the other solution is negative 1 minus root 37I divided by 2. Those are your two solutions, but let me give you one more way to write it, just in case. Another way to write that would be to split up the fraction. So negative 1/2 plus root 37I over 2. And the other one would be negative 1/2 minus root 37I over 2. Okay? So just two different ways you can write your solution. Either one is correct. For example 5, we're going to solve one more using the quadratic formula. It's very similar to the last one. We know we're going to end up with a solution that has the imaginary number I in it. Okay, so recalling back, how do we do the quadratic formula? Well, we can't use the quadratic formula until we have it in the right form. So our first task is to rewrite this in the correct form. So I'm going to take my 4x and my minus 13 and move it to the left-hand side. I'm going to do that by subtracting 4x and adding 13 to both sides. That's going to leave me with x squared minus 4x plus 13, and now equals 0. I have the 0 on the right-hand side. Now I can identify my A, my B, and my C. My A is 1, my B is negative 4, my C is 13. Then I can begin plugging into the quadratic formula. So x is equal to the opposite of b, so the opposite of negative 4, plus or minus the square root of negative 4 squared, minus 4 times a, which is 1, times c, which is 13. All of that divided by 2 times a, which is 2 times 1. And then begin simplifying. X is equal to, the opposite of negative 4 is a positive 4. Plus or minus, now be careful, this is where people make a mistake. Negative 4 squared is a positive 16. If you're typing that into your calculator, you have to be sure to use parentheses. Minus 4 times 1 times 13 is 52. All of that divided by 2. Continuing to simplify, I have x is equal to 4 plus or minus 16 minus 52 gives me a negative 36 divided by 2. I'm going to go to a new screen so I can continue this problem. So again, I was left with x is equal to 4 plus or minus the square root of a negative 36, all divided by 2. Now let's look at that square root of negative 36 on the side. I know that that is the same as the square root of negative 1 times the square root of 36. We know that the square root of negative 1 is I, and we also know that the square root of 36 is 6. So this one's a nice one for us. We can write it as 6i. So coming back over here, I now have x is equal to 4 plus or minus 6i divided by 2. And again, I'm not done because I look at these whole numbers out here. We don't have any radicals to deal with, and I see that they're all divisible by 2, so I have to reduce them. That leaves me with x equals 2 plus or minus 3i, and this would be divided by 1, so I don't have to write that. That gives me two solutions. The first one is 2 plus 3i, and the other one is 2 minus 3i.